Thank you so much for allowing us to be here. This is the ethics and philosophy section of the quantum computing conference, and it's incredibly important actually, because you have this moment right now, I think, with quantum computing where we all know it's experiencing tremendous technical developments, and we all know that it should reach what we think of its full potential. The impact on society and business is going to be huge, and like any powerful technology, quantum can be used for very good things. It can be used potentially for not so good things. So exactly how that's going to develop remains to be seen. And I think all we have to do is look at other fields of tech, like social media, for instance, AI to a certain extent. And you can know that it would have been great to be thinking some of these questions, thinking through them early on in the development of the technology, not after those effects have already been felt, when it's also quite hard to change at this point. So we're going to try to talk about what kind of ethical approach really quantum computing should have. Does it need a new approach, maybe that's different from other kinds of technology? And we have a great panel with us here. To my right, we have Catherine Lefebvre, is the Innovation Ambassador at M², where she works on quantum and international collaborations. Mehran Sahami is the James and Eleanor Chisborough Professor in the School of Engineering at Stanford University. Joan Hoffmann is the Exploration Program Area Manager and Acting Program Manager for Alternative Computing Paradigms at the Applied Physics Laboratory Research and Exploratory Development Mission Area at Johns Hopkins University. It's a very long title. Sorry about that. And last, we have Eliska Creplova, the Assistant Professor at the Department of Quantum Nanoscience at Delft University of Technology in the Netherlands. So I want to start actually just trying to define it. At this moment in the field's development, what do we identify as the major ethical questions quantum computing really has to answer at this point? And it's often hard to know before something fully develops, okay, what will the problems be? So we want to get ahead of that. Just anyone to start off with, what do you think what do we have to start with first, I suppose? Feel free to, do you want to start, or?
Maybe
go ahead, yeah.
just to kick it off, let me maybe start with the one that is, I think, like super near term, and it's not like specifically related to the quantum computing, but I think it kind of ties into all this stuff that were discussed in the plenary in the morning, and that's equity in access to these technologies. And this is so closely related to the questions of diversity and having actually a supply of competent people who can feed this industry that is growing really fast. And even though this is not an ethical risk that is specifically quantum, I think I would even say it's like an ethical opportunity, because we are this new young field that is growing really fast. So maybe we can address these questions of being inclusive and caring about open science and training the diverse group of people to join us in a new and creative ways. So I think that's a one.
I couldn't agree more with that. I think that question of access and about who is going to build the future of quantum is an incredibly important one. And as we sit at a place in quantum where we're still trying to imagine some of the near and medium term impacts of quantum technology, we have these ideas about what we'll do a very long time from now with a quantum computer, but we're still not sure exactly what we're going to be doing with these NISQ machines and what comes right after NISQ machines. The people who will create that future are the people who are now having access to quantum machines, developing new algorithms, developing new applications, and who imagines those will influence the sorts of impacts that quantum will have in society.
Yeah, I'd agree with that. I mean, I think the parallels that you brought up with AI and looking at the development of where we're at there, because that's my background is in machine learning and AI. And now where we're at in quantum, it's, you sort of look back, maybe it's, behind AI in terms of commercial application by a 10 or 20 year horizon. But if you look at the development, and it's still ongoing, of ethical thinking in the AI community, a lot of the harms that were pointed out early on were pointed out by Black women because they were disproportionately impacted and they were not well represented among the researchers that were developing the algorithms and were creating the data sets that were used. And so, I think that's very telling. If you don't have a diversity of people in the room, the problems that those people might face as a result of the technology are not addressed in the same way. And there's certainly going to be, even for non-researchers, there's going to be distributional impacts of quantum the same way we're seeing them come up with AI now. And so getting those diverse viewpoints, not only among the research community, but actually among outside agencies that are also paying attention to how the technology is developing, is pretty critical.
And giving access to education and training, right? And beyond, like also including the global south and like how to reach different communities. They're using different platforms, different tools, and we have the chance to reinvent a bit and be more creative in how to include those who want to participate, not just the access of the benefits, but also participating in creating these new applications. I think that's on the access part. And then also, as you mentioned, with analogy with AI, or when we combine quantum and AI, quantum machine learning, then you have a whole new set of challenges, ethical challenges in like biases and access to data and data privacy. These are questions that are not fully answered just in AI. So how do we transpose that to quantum? I think that's to take into account.
Well, that question, the question of access is one that's come up a few times already at this conference. How do you begin to ensure that if everyone, but more people in a broader and more diverse group of people actually can have access to these technologies? This is still fairly nascent. It's very complex. So is it via education? Is there another means to ensure that, this is not just held for those who have the resources to afford them, I suppose?
Well, I do think that one interesting opportunity for quantum is the fact that so much access right now to early quantum machines is via cloud platforms. And so if folks have access through the internet to those platforms, in some ways it's more available for experimentation, because it's often that early playing with a technology, with a computer, that starts giving people ideas about the thinking that will develop some of those algorithms and applications. And there's been some scholarship on the shift of computer science from a more gender balanced field to more male dominated. That shift corresponds with the rise of the personal computer rather than mainframes or what we now call cloud access. So there may be an opportunity to avoid some of that bias in the quantum ecosystem because of the nature of the hardware.
But we're looking at ethical concern and impact of the society of quantum technology.
Right.
What I don't hear often, or maybe I hear, I just miss that conversation, is educating not only the public about what quantum is and what it means and what it can do now and cannot do, is also educating the scientists, the researchers, the quantum scientists about social science, about what it means, social science, and what understanding the social impact so that they can incorporate that into their research and development. And when I was doing research myself, I never had such kind of training, and maybe it's time to incorporate that in our curriculum.
Yeah. And just the fact that science is something that it's a human endeavor. Scientists are doing the research, and inevitably the perspectives and even the biases of the people doing the work suffuse the work. And I think there's little awareness of that in our training of how that plays out.
At this point, can we begin to identify what some of those social impacts will be with quantum computing? It's obviously we can see again with other areas, but is it possible to know what those disparate impacts might be? If we're trying to predict and sort of prepare for what could go wrong, which I think is an important part of thinking about this, is that clear at this point, really?
Well, I think one way like to think about ethical issues is what's the trade-off that's involved, right? Because usually issues of ethics are issues of value trade-offs, and that's why there aren't clean answers. That's why there isn't a right answer, and it's hard for scientists to grapple with those issues because I think a lot of times we look for what is the right answer as opposed to better and worse. But if you look at, crypto, which I think is the big area, right, that everyone's kind of worried about, encryption puts a heavy thumb on the scale of privacy. And if you think about that value trade-off, what is the alternative to privacy? Because people think, well, privacy is an intrinsic good. But if you think about, say, an end-to-end encrypted messaging platform, the trade-off there is you also have people who are trying to violate national security or personal privacy, like human traffickers, child pornographers. They can send things through these encrypted channels. So when you have full end-to-end encrypted technology, you put a heavy thumb on the value of privacy. Whether that's through a democratic process or some other political process, but those viewpoints need to be brought in.
I think another challenge with quantum right now is that, as you've written about, Bryan, people have trouble imagining the future. We're often challenged with that. And sometimes, though, it's almost that we do a better job imagining further out in the future than in the near term. So we can start to think about what would happen if we had a quantum computer that could factor large numbers and what the implications would be, and start having that conversation about the value trade on privacy versus not. What we're not perhaps doing as good a job of imagining as what we're going to be doing with quantum computers in 1, 3, 5 years, and what those value questions will be grappling with then. You look at something like AI, where certain people have spent time worrying about what happens when we get to the point of superintelligence, but we failed to think very hard about machine learning algorithms doing risk analysis for prison sentencing and the disparate impacts that would have. And so what are those questions going to be for quantum in the next handful of years? If we do achieve some of these optimization algorithms, what are we optimizing and what value trades will we be making? If we achieve these quantum assisted machine learning, what will we be doing and what will the conversation need to be? And I don't know if we've imagined enough yet there.
Well, it's very difficult to imagine, I think, and also because you're right, quantum seems to exist in that way where we can imagine, the full potential of it, the simulations you'd be able to do, the materials you'd be able to create, that all sounds amazing, but figuring out that's going to be a matter of the choices that are made, presumably over a year from now, 3 years, 5 years from now, as those machines evolve, and that's the hard part, I think, because there are competitive pressures. Obviously, there are geopolitical pressures as well. It's just kind of it's difficult, really, I suppose. And I guess one area I wonder is with anything like this, and I think back again to other technologies that have burst through in this way, is are there applications that just shouldn't be worked on, perhaps? Are there things that quantum computers can do or may be able to do that are inherently too dangerous? And I realize that's a value-laden term to use, but that's one way that could be helpful, perhaps, in terms of beginning to understand what that might be. I mean, again, go back in time, thinking about much bigger issues like nuclear weapons. There were choices made under certain conditions, but here, are there things that we shouldn't be doing with these machines, or we should put them off limits, I suppose?
We're so early in the technology to put regulation and say, don't do that, don't do that.
Well, I was thinking even just in terms of the field itself.
Yeah, my point of view is that every application, every technology can be done for good or for bad. And that's the responsibility of the technologist to understand what is good and bad. And then example that I have in mind is that there are the United Nations put the 17 sustainable development goals. And if we work towards application of quantum computing and other quantum technology to the SDGs, this is for sure going to be good. We're going to have concrete example, demonstration of quantum computing and for the benefit of the global society, and then build on that, I think, more than finding the first application on surveillance or design a new drug or a new material that can become a weapon instead. So if we understand the global challenges and works towards that, I think that can be defined as good, and understanding that, taking the responsibility on that side.
Yeah, I also think it's throughout this process is super important to acknowledge the difficulty that we've been already discussing. It's not that we can now reduce it to some quantum trolley problem and, okay, let's think about what's the ethical choice, right? Like there is like, just like example I am thinking about, like, let's say one of the near-term applications, quantum chemistry. Maybe we can think about, okay, it would be so scary if there is one company who can run all the experiments for all the possible drugs in parallel while other countries, other people are spending months and months doing it by hand. But at the same time, we don't have that technology now, and we don't have an equitable distribution of the medicine and vaccines just because of the policy reasons. So in the end, there are questions that are not necessarily bound to the technology itself and to this simple models that we imagine for it, because there will be so many things that comes from the policy and applications. So I think it just sort of all comes around to this inclusivity and openness in treating these things.
Is that issue around openness, I wonder, when it comes to looking at the international dimensions of this, and this is a little far from the ethics, but of course this is we see the United States pushing ahead with quantum computing, other countries as well, both allies, both competitors, I would guess. And I wonder, in the past, again, with thinking about emerging technologies, when there's a power race dynamic that can pervert the course of it, that can create different motivations, that can make it harder to make ethical choices. I don't know if we're at that stage now for quantum, but is that a possibility? That's something that could be headed towards our way soon, where those pressures could change how we approach it, I suppose.
So maybe to throw out a controversial statement, which is actually not from me, it's from Yuval Harari, who's a historian. And he said, he was when talking in reference to AI, I think it's also true to quantum, is that AI favors tyranny. Right, and I think the same thing could actually be said of quantum. Is if you have any system that favors a concentration of technology, of data, of the ability to do that kind of analysis, is an aid to basically an authoritarian regime, right? In a regime that has a tendency to want to be able to concentrate data and power in carrying out the agenda of that regime, has a particular vested interest in a way that a regime that is more of a polity does not. Now, that's a controversial statement. I'm not sure I agree with it entirely, but I think at some level, if you look at, when we talk about openness, if you think about now in terms of big tech players for established technology, who has a race ahead? It's people who have the concentration of data to run through machine learning algorithms and the large cloud clusters to actually be able to analyze that data. And so what do you get as the countervailing forces, like the push toward having a national infrastructure, right, that's more accessible to more people, safeguards around the ways data can be concentrated, what are the privacy implications there? And so thinking about, and this is kind of, trying to build the engine while the plane's in flight. quantum at least has a luxury to be able to think about those things before the technology is fully developed. And so I think part of that question is, imagine a world in which that power and technology is concentrated versus one in which it's distributed. Then that brings up some of the value trade-offs to the fore and helps drive what might be some of the policy considerations to push more toward that distributed world.
Does quantum have that same characteristic where if you have the concentration of data, if you have the concentration of compute power, you will have a definitive advantage in the same way that we've seen with AI, or can quantum be developed in a different way for anyone?
I mean, I think that there are certain commonalities, perhaps not the data commonality, but right now when we're in a nascent stage, there's just the talent issue in the workforce. There's pipeline, and perhaps heading towards a future where you have a concentration of hardware also. As we move towards this kind of localized compute hardware with cloud access, as opposed to the distributed computing that we have now.
Talking about the pipeline issue, because that is incredibly important. If we're going to have more diverse viewpoints, we need to get a more diverse workforce. Do we have good ideas about how you begin to do this? Again, this is something we've seen in tech more broadly. You have a chance to start a little earlier with quantum. How does one actually change that? How do you actually change the characteristics, the makeup of the people who are actually doing the work in the quantum workforce?
So maybe I can say an idea that is not my idea right now. I'm reading an excellent book by Professor Chanda Prescott-Weinstein, and she is the first Black woman ever who is a professor in cosmology and astrology, and she has super, I think, helpful and structured perspective on this. Basically, what she says is that we spend a whole lot of time creating arguments for us why we should be more inclusive of other people, because we say, okay, it's a right thing for the historical reasons, or we have a pipeline problem, so let's treat these other people as a resource. And in all of this thinking about how to diversify us, we don't think so much about communicating to others that there is a space for them, even if they are not, PhD from Harvard, 1 million startup, MacArthur Genius Grant kind of winners, and that there is opportunities to make changes at all the stages, and our quantum computing community is open to them and welcoming them and concentrating on that instead of thinking about how to benevolently accept some outliers, but instead of really sending the message, this is the place where everyone can make a difference, I think could be incredibly helpful. And it really ties with this fact that we are just starting out. Big parts of this technology are still in a pre-competitive stage. So I think we really have a great opening to reframe this message from this exceptionalism to something more inclusive, and the final result of that will be that it solves big part of these problems, I would say.
Is it possible to help people actually see how these can work? Is that one way? I think you mentioned the PCs and how when classical computing went from sort of centralized mainframes, or it's in people's homes, it does open it up to a wider group of people, maybe, who could afford those. That's one thing. Quantum still feels like it's something I talk to people who have nothing to do with quantum computing about this, and they sort of have heard about it, but they don't. It sounds like the most complicated thing you could possibly imagine: quantum physics and computers together. But is it possible to begin to get it out there to people so they can even experiment with it, younger people as well, and students even pre-college, and get a sense of how it works, even if that is just really to help grow that workforce, both in terms of numbers, but also in terms of diversity, I suppose.
Yeah, there are more and more initiatives on outreach and education. Like in the US, this qubit by qubit is helping, bringing quantum to kids, and so they can code and play with that. And I guess in the Delta Quantum Delta Netherlands, they have their program too, and then also giving access more opportunities for women to go to conferences that was announced yesterday. This is amazing. all the outreach program is something that just needs to continue and bubble up. And I'm just having a thought that how to reach communities that are less represented, like in Africa, for instance, that like everyone, we're all human, we can all contribute to the advancement of this technology. And different communities, different countries, they're using different platforms and tools. And one of my mentors has organized a conference. I was a quantum in South Africa, and they were using WhatsApp to reach the community. And so it's just they have to adapt to different communities to do the outreach and have a common language and finding what is that common language for different initiatives and different communities.
In terms of, again, thinking of the future, I mean, we've talked about AI a few times, and I'm just wondering, some of you actually were working in AI even before you're doing quantum. Are there specific examples you can look back to the development of AI where you can think, okay, that's a specific lesson we can take for quantum computing? You know, whether it's, you know, something like facial recognition. I mean, that's a powerful technology that developed very quickly, it felt like, and became commercial very quickly. And I'm wondering if that's an area. It's one thing to develop something in the lab. It's another thing if startups start taking it and marketing it around. I'm not sure anything in quantum is at that level yet, but I'm just curious if there are, okay, certain points of comparison you can see and say, all right, well, we know that didn't work out so well in this other field. We in the quantum field should be thinking of going in a different direction.
I mean, to me, one of the lessons there, and this has been mentioned already in this conversation, is the fact of who is in the room and who is doing the work really influences the output. And I think that's something we have really learned from AI and machine learning, that the cohort of folks who push the field forward have influences they don't even realize at the time on what then comes out of that research and gets pushed out to market or to the general public. And it speaks to that need of having a broad representation in the room of folks who are bringing different perspectives on both what goes into the research and what to do with what comes out of it.
I think there's also an inflection point in AI probably about 10 years ago now, maybe a little bit more depending on, you know, who you talk to. But, you know, the research in the field had been going on for years, but it hit a point where you got a confluence of three things that really spurred commercial development. You got enough data that was being gathered in a centralized way. You got compute infrastructure that was now powerful enough to generate these, you know, 100 billion parameter models that show just, you know, orders of magnitude, or not, well, orders of magnitude, depending on how you look at it, you know, a step function increase that moved the technology from that's a nice technology in the lab to be human competitive. And at the same time, you got some interesting algorithmic development that allowed that inflection to happen. And that happened over a relatively short period of time. And, you know, that thing I think about quantum is the same way. I mean, we're still in very early days where it's like, let's get some of the basic technology issues figured out. Let's think about interesting algorithms. But I don't think there's going to be a difference with respect to at some point there's enough, you know, however you want to measure it, computes of computation or the computing infrastructure to actually be able to solve problems that are interesting, where you now sort of get quantum supremacy on a lot of problems as opposed to just an interesting lab problem. And you get a ubiquity of being able to use that to try to solve a bunch of different problems. Then the financial interest will kick in. You'll get people trying to solve a bunch of different problems, some of which are unsavory from an ethical standpoint, because there's a commercial interest in doing it. And that will happen quickly. And there's two ways the field can go. It can either react to it after it happens, which is what AI is trying to do, right? And we see that struggle with facial recognition, a bunch of other things. Or you can try to think about it before, which is actually there's models for that from the field of bioengineering, right? So the CRISPR technology was developed, right? Jennifer Doudna and some of the other people who actually developed the technology said, we're going to get together and we're going to, from a scientific standpoint, create a moratorium on the use of this technology to edit the human genome, right? That was before commercial interest kicked in and said, let's create designer babies. There was one scientist who violated that norm. He's now in jail, which you could say is actually a pretty extreme outcome of it, but it was disinvited from the scientific community, is not welcome at any conferences, right? There's this ethical norm that came to play in that field. We don't have that developed in the same way in computing. And quantum actually is out front. So they have an opportunity to develop this before you get the externalities.
That's so interesting because, I mean, Professor Downer, she was looking, I think, even back to the Asylum conference in the early 70s with releases of genetic engineering. And that's really, I think, been a landmark when it comes to, okay, here's a scientific field setting rules for itself. Do you need something like that in this field? I'm not even sure. That also comes from the fact that medical science and bioscience has, I think, a deeper, not interest in ethics, but just it's put into the field more practically than it has been in tech more broadly. But is something like that a good idea? I mean, do you need something that this isn't just one part of a big conference like this, but actually here's the focus? And that also means thinking about what we should and shouldn't do. And I think that's important to think of. I come back to that question again, like, are there things, okay, we shouldn't do designer babies. Are there things in quantum that also we should not be doing along the same lines? And maybe that's not clear yet, but I'm curious if that's an idea that's come to people yet.
I don't think it is something that people are grappling with. I think with biotechnology, there always has been, and that obvious line to draw of what the human implication will be. And for so long in computing, we've been able to abstract away the computing progress itself from the human implications for it. And perhaps AI is really where that started colliding more specifically, because when you talk about kind of, you were alluding with AI, you talked about that confluence of the algorithms and the data and the raw compute power that really caused this inflection, and then also generated that virtuous cycle that was seen for so long in classical computing. But in that case, it was seen merely as technological progress. It didn't speak to directly human impacts.
Right. Yeah. So that's I guess that's the stage we're at now, where we're trying to figure out what those questions will be as you build the engine while you're flying the plane. Hopefully it's going in the right direction.
We're not really flying yet.
Yeah, okay, so, right. Not quite flying. All right, building the engine as you're getting ready to take off, I suppose. I think we're but just about at a time, and I don't want to run into the other panel's time as well. So thank you to our panelists here. Sorry about the emergency. I hope it wasn't a serious emergency and all, but thank you very much. Appreciate it.
Thank you.